Hi everybody, in this tutorial we're going to practice one of the applications of GIS in the study of vector-borne diseases. We're going to see the density of major ticks in Arkansas. The data were obtained from Arkansas Department of Health for the years 2017 and 2018. In Lab 4 folder, if you open up your ArcMap, if you open up your ArcMap and then navigate to Lab 4 folder, here we have two shape files, Arkansas. This one is the boundary of Arkansas, and the other one is the location of ticks in Arkansas. We also have another new file with the name of digital elevation model, which represents elevation as a continuous surface in Arkansas. This shows it's a grid of cells. So we will talk about the digital elevation model at the end of the tutorial. So let's add both of the shapefiles, boundary of Arkansas and location of ticks, into ArcMap. Each point on this map represents a GPS coordinate for at least one ticks. If you open up the attribute table of tick under Arkansas, so we have more than 7,000 ticks recorded in Arkansas. So here we have the name, the scientific name of the ticks, and also latitude and longitude, and also the name that is common, that the common name of the ticks. Okay, so we have a variety of ticks in Arkansas. For example, Lone Star tick, brown dog, black leg tick, brown dog tick, American dog tick. Also we have Gulf Coast tick, and these are the most important ticks in Arkansas and also in the United States. For example, American dog tick or wood tick can cause tularemia and Rocky Mountain spotted fever. The other one is Lone Star tick or northeastern water tick, which is indigenous to much of the eastern US and Mexico. And a bite of Lone Star tick can cause people to develop allergy to red meat. Another important tick was brown dog tick, which can be found throughout the United States, especially in warmer climate and higher humidities. This tick can also transmit Rocky Mountain spotted fever. Gulf Coast tick, which lives along the coastal areas such as Atlantic coast and Gulf of Mexico, is another common ticks. And most importantly, black leg tick or Exodus scapularis, which can be found in northeastern and midwestern United States, and it can transmit Lyme disease. So if you Google distribution of ticks in US, distribution of ticks in US, and in the first link, I think this one, geographic distribution of ticks that bite human. So we have American dog tick, and here we can see the spatial distribution of American dog tick, and also where it can be found, it can transmit what type of diseases, and also black leg tick, which can causes Lyme disease, also known as Exodus scapularis. That's the scientific name of it. So it's more common in the northeastern and midwestern part of the US. That's why we have higher number of Lyme disease in these areas. We also have brown dog tick, which is, as you can see, is common across the US. Gulf Coast tick, which is very common to the coastal areas, and Lone Star tick, Rocky Mountain wood tick, and finally Western blackleg tick. So these are the most important ticks in the United States and also in Arkansas. So in this lab we're gonna see the concentration of different type of ticks in Arkansas to help policymakers for future control planning. First of all, if you open up your ArcMap, we need to make separate layer for each major ticks in Arkansas. So if you go to the selection menu, select by attribute, I'm gonna select the ticks one by one. Okay, select the type of ticks, for example American ticks, and also a layer for American dog tick, a layer for scapularis, Exodus scapularis, and so forth. So here if I double click on name equals to get unique value, and then American dog, verify, okay, apply, okay. So here you can see that these are, if you want to make sure that these are only American dog tick, you can right click properties, right click, open attribute table, and then click show selected records, and here you can see that all of them are American dog tick. So we need to make a layer from American dog tick. So if you right click data, export data, and then in the lab 4 folder with the name of American underscore dog, data type of shapefile, and save, and okay, yes. And then don't forget to clear selection, and also you have to repeat this step for all of the other ticks. Okay, select by attribute, clear this selection, name equals to blacklegged, verify, okay, and then export it. So make sure it's only blacklegged. Okay, so we haven't selected any. That's weird, because there are some, because we have to open attribute table of the ticks, not the American dog. So we have to open attribute table of this one and blacklegged, okay, and then export this one, data export, and with the name of black underscore legged, which causes Lyme disease. Save, okay, export it, clear selection, select by attribute, clear, name equals to the third one, brown dog, verify, okay, apply, okay. So make sure it's brown dog, yes, and then export it, data, export data as brown underscore dog, save, okay, and yes. Clear selection, tick Arkansas, open attribute table, sorry. So we have no selection. Select by attribute, remove this one, name equals to Gulf Coast, verify, okay, apply, okay, open attribute table of this one, Gulf Coast, and then we can export it. Lone Star, verify, okay, apply, okay, and this one is Lone Star, so we can easily data export it as Lone Star. So we have only, so most of them are Lone Star. 5,000 out of 7,000 is Lone Star. So clear selection. I think we only have a few number of winter. Let me see. Selection, select by attribute. Winter tick. Save. Okay. So we only have how many? 4. So we can disregard to make another field for this winter tick. So we're gonna focus on 1, 2, 3, 4, 5 ticks that are common in Arkansas and also in the United States. The next step is to create a surface that shows density of ticks in Arkansas for each of the ticks. This is an example of a spatial analysis. We need to make sure spatial analysis extension is already activated. So how we can activate a spatial analysis from customize menu, extensions, and make sure to check spatial analysis. Okay, otherwise you won't be able to use the tools. Okay, you will get the warning. So click check the spatial analysis and then close. And after that, now you can open Arc Toolbox, which has numerous tools in ArcGIS. Expand spatial analysis tools and then density and kernel density. Okay. We're gonna make a continuous surface that shows the density of ticks. For each tick we have to do this. Okay, so let's do it. So the point feature should be, let's start with American dog. American dog. So here we don't have count for each location. For each location we only have one. It represents only one location of the ticks. So population field, if you click on show help, it has some description. What does it mean? Okay, for population field can be none. Okay, so use none if no items or a special value will be used and each feature will be counted once. So sometimes each location shows maybe 10 or 20 number of ticks that they found, but here we don't have that type of field, so we consider this as only one. So and then where do you want to save your raster? So this is a raster or continuous surface. So we're gonna save it in the lab 4 with the name of American dog _ dog and then save. So let's leave other fields as it is, and then but here you need to also click on environment and then go to the raster analysis. You have to set a mask, which means the process should be only done within the mask, okay, not outside of the mask. So we're gonna limit our calculations only within the mask or only within the Arkansas, not outside of Arkansas. So we have to select Arkansas as a mask and then click OK and OK. So this is still running. It takes a few seconds for running the calculations. Okay, here is the results, but we can't see it because we have to change the order of layer. If I put the result on top of the other layer, we can see the result. But if I right click properties, we have to change the symbology. If I use 5 number of classes to 5 And also the classification. This one is equal interval, which means that the range for each class is equal. But this is not really realistic. So one of the realistic way to classify your data is based on natural break, which finds the natural gaps between, looks at the histogram and finds the natural gap. And if you change this to natural break, so in the natural break the variations within each class is minimized and between the class is maximized. Okay, so natural break, and then click OK, and then so here you can also change the color ramp, for example this one, and then apply and OK. So here you can see the distribution of the spatial distribution or density of the American dog tick in the Arkansas. Okay, so we have to repeat this process for all of the other ticks. So as we're gonna make 5 different maps, so it's better to insert a data frame, and in this data frame for the other one, which is black-legged. So I change this to, or you don't need to, or okay, black-legged, and then I copy black-legged to here, and then make a map from the black-legged and also from the Arkansas. So again, you have to go to the ARC toolbars, kernel density, input feature should be black-legged. You can select it from here, or you can drag and drop here. Black-legged, population field, none, output raster as black-legged. Oops, what's the problem? So I think we shouldn't use the space. Okay, so and also environment raster analysis, the mask should be Arkansas, and then okay, everything looks good. Okay, and also change the symbology again to 5 classes, natural break. Okay, this one, the same symbology we use for the purpose of comparison, and then order of the layer. So you can see that the distribution of black-leg in Arkansas. So you have to repeat this process for all of the 5 ticks, and after that you have to go to the layout view and make a map for each one. One thing that you can do is to change the orientation of the maps, for example from file, page and print setup, orientation, landscape, and then okay, and then here you can put your maps. So 1, 2, 3, 4, 5, and also so you can do this process. You can create the map for each of the ticks. Don't forget to add a title for each of them. Okay, and the other thing that you should do, north arrow, scale bar, your name, and the source of the data, Arkansas Health Department of Health. And another thing is about the digital elevation model. Okay, so let me add another data frame with the name of digital elevation model. And then copy Arkansas here, and after that add the digital elevation model, close, change order of the layer. So this one is digital elevation model of Arkansas. So this is a like the others, this like the black-leg tick, or the result of the kernel density. So these are raster data sets. They are not point line polygon. These are used for continuous variable, for example for temperature, for elevation, that are that exists in everywhere. So we have to use a continuous surface to represent elevation or temperature. So this is called a raster data set, and if you use identify button, and then you can see the pixel value shows the elevation for each location. Okay, so here for example elevation is 64 meter, here elevation is 366, so here we have a higher altitude. Okay, so here again you can change the symbology of the digital elevation model to this one, and this time if you click apply OK, so you can see that these areas have higher elevation. Okay, and these areas have lower elevation. So you can also add the digital elevation model to your map, or maybe in other color if you want to differentiate it from the other ticks. So I don't know. So this one is good, but maybe if I invert the color ramp, so these areas shows higher elevation, these areas have lower elevation in Arkansas. So you can compare the location of the hot spots. For example, this one, the hot spots of the American dog, okay, with the elevation. Okay, you can generate some hypothesis that maybe there is a relationship between the occurrence of the American dog tick and also the elevation. Or you can compare this American dog tick and elevation and then compare it with the previous literature reviews, whether they found elevation or altitude is an important risk factor or not. Okay, so you can add 1, 2, 3, 4, 5 ticks and also elevation here, information about yourself, and other necessary elements. Okay, North arrow, scale bar, information about yourself. And in your write-up, it's very good in the discussion section, especially, that you can talk about the role of elevation for each of the tick-borne diseases, for each of the ticks that are common in Arkansas.